Good morning, children. This is 12th Physics, Chapter 3, Current Electricity. Today we are going to cover the topic that is EMF. EMF, terminal potential difference and internal resistance. Last class we had started with EMF, that is, it is the maximum potential between the two electrodes, between the two plates of the cell, between this, when the cell is not connected to any external circuit, when no current is drawn from the cell. At that time, the potential that exists between the plates of the cell is maximum, and it is EMF, that is electromotive force. Next we did the term that is internal resistance. Today we will do it in detail, right? It is the resistance which is offered by, the electrolyte solution, to the flow of positive and negative ions inside this solution. That is your internal resistance. Right, children? Now, internal resistance, it depends upon these four factors. We did it in last class, right? Terminal potential difference. This is what we are going to understand in depth today. Now let us consider a lead acid battery. This is your lead acid battery. Now, inside the lead acid battery, it consists of two plates. This is a plate number 1. This is a plate 1. This is a plate 1, and this is your plate number 2. Right, children? The first plate is made up of lead dioxide, that is PbO2, and the second plate of the lead acid battery is made up of lead. Now, inside this, the solution that is used as electrolyte is your aqueous sulfuric acid, that is H2SO4. Now we know that battery converts chemical energy into electrical energy, right? So inside the battery, chemical reactions takes place, and during this chemical reactions, energy is released. The same energy is released by the battery for its operation. Means when we are using the battery, it gives us energy, right? So from where does it get energy? It is the same energy that is released during the chemical reactions that is taking place inside the battery. Now let us see how the charge gets accumulated on the two plates. Because of the accumulation of the charge on the two plates, the potential difference is set up across the plates, and this potential difference is your EMF, right? Now what happens is, in aqueous H2SO4 over here, in aqueous H2SO4, it splits into two hydrogen ions. It splits into two hydrogen ions and one sulfate ion. It splits into two hydrogen ion and one sulfate ion. Now what happens is, the H plus ion, your H plus ion, there are two H plus ions, right beta? Now these H plus ion, they react with the PbO2, that is lead dioxide plate. उससे react करती हैं. And what does it do? The H plus ions reaches the PbO2 plate. ये यहाँ पे movement होता है इसका. Let me show it to you over here. यहाँ पे है H plus है ना बेटा, ये H plus है आपके, ये आपके H plus है. So what happens? This H plus, they move towards the PbO2 lead dioxide plate. They move towards them. and then what do? They release the charges on the plate. इसके पास positive charge है, so H plus ion, it leaves the positive charge on the PbO2 plate, that is lead dioxide plate, and so the lead dioxide plate becomes negative, becomes positively charged because of the positive charge which was released by the H plus ion, right? And after releasing the positive charge, the plus H plus ion, that is your H plus ion, no longer remains a positive ion. It is converted into a nascent hydrogen. It is converted into a nascent hydrogen. This nascent hydrogen is very reactive. अब ये बहुत reactive है. So what does it do? It reacts with the nascent hydrogen. It reacts with the PbO2 plate. इस plate के साथ react करेगा and what does it form? It forms PbO plus H2O. Now this PbO is an intermediate product. Okay, this will be further used for the reaction. So the hydrogen ions, here these are your positive hydrogen ions, they react with the lead dioxide plate and they leave their positive charges on that plate, and what they become? They become a nascent hydrogen, which is very, very reactive, and it reacts with the PbO2 plate and it forms PbO, that is an intermediate product. Now this PbO that is formed, अब ये जो बेटा PbO है, it will react with the sulfuric acid, and when it reacts with sulfuric acid, it forms PbSO4, right? That is lead sulfate plus hydrogen molecule is released. So if we see the conclusion of these two reactions, then we will see, children, that the final reaction is PbO2, it reacts with the two nascent hydrogen and sulfuric acid. And what does it form? It forms PbSO4 and two molecules of hydrogen. It forms PbSO4 and two molecules of hydrogen. Understood? So, and similarly, ठीक है बेटा, H plus ions, they move towards this plate, right? Now, we are having here the sulfate ion, SO4 minus minus, right? This sulfate ion, it reacts with the lead plate. It moves towards the lead plate, right? And it reacts with the lead plate and it leaves its negative charges on the lead plate. वो अपना negative charge release कर देता है lead plate पे. And as you can see, the lead plate becomes negatively charged because of the negative charge released by the sulfate ion. और एक बार उसने charge release कर दिया, now beta, it becomes radical sulfate. Now it becomes radical sulfate, right? And this is again very, very reactive. ये बेटा बहुत reactive होता है, right, children? So you can see that by this process, continuously positive charge is deposited on lead dioxide plate and negative charge is deposited on lead plate. Now, so by this process, the charge gets accumulated, and due to the accumulation of the charge, potential difference is created between the two plates. And this potential difference keeps on increasing with the increase in the charge accumulation. जैसे charge यहाँ पे accumulate होता रहेगा, as the charge goes on accumulating, the potential difference between the two plates also goes on increasing. But till what extent it will increase? It will increase to a particular value, and that value is E. So E is the maximum potential difference between the two plates of the battery. Now, after this, what happens? When the maximum potential difference is gained, after that, what happens? This is positively charged, right? This is at higher potential, and this plate is negatively charged. This is at lower potential. So what happens is, now the H plus ions, they are not able to move towards the PbO2 plate. अब ये जो H plus ions है बेटा, right? They are not able to move towards the PbO2 plate. Why? Because the PbO2 plate is now positively charged, and H plus ions, they are also positively charged. So because of the repulsive force, because of the electrostatic repulsive force between them, the H plus ions no longer are able to move towards this plate. Similarly, the SO4 ions, they also experiences an electrostatic repulsive force, and so they are also not able to move towards the PbO2 plate. No, now they are not able to move, right? So this is the maximum value of EMF. Now, if this we connect it with now the two plates, if we connect it with a voltmeter, अगर हम बेटा voltmeter के साथ इसे connect करते हैं, then you will see that voltmeter will show you the potential difference in volts, right? So that value of potential difference between the two plates, when you are not connected any external circuit, कोई resistor connected नहीं है, no bulb, no nothing, right? So at that time, when the circuit is in open condition, the potential difference between the two plates is maximum, and it is the EMF, that is E, or you can say it as sigma, right children? So children, this is your EMF. So if you want to define EMF, we can say it is the maximum potential difference between the two plates. It is the maximum potential difference between the two plates of the cell when no current is drawn from the cell, right? Or when the circuit is in open condition, right? Okay, EMF, we got it. Now, when we are connecting an external circuit, अब हम यहाँ पे here you can see that we have connected a resistor of value R over here. So we have connected an external circuit over here. है ना बेटा? Now what will happen? Now we know that as PbO2 plate is at higher potential and lead plate is at lower potential. So we know that the current will flow from higher potential to lower potential. So here you can see the purple color line shows you the direction of the current, that is from the plate at higher potential towards the plate at lower potential, right? And opposite to that is the direction of your electric field E, right beta? Sorry, opposite to that is the direction of your flow of electrons. Electrons are flowing opposite to the current, right? Now what happens? As the current will start flowing, as the current will start flowing, the charge that is accumulated, right, will go on decreasing. अब जो charge accumulate हुआ है, the potential over here will go on decreasing. The potential here will go on decreasing because electrons have started moving from here and they are coming over here. So there is loss of charges. पहले accumulation हुआ, now there is loss of charges. So because of the loss in the charges, now the potential difference between the two plates will be reduced. अब जो potential difference है, that won't be E. That is not going to be E. That is going to be less than E. That is not going to be E. That is going to be less than E. Okay, children. So what happens is now This is the same thing. Okay. Now, so children, we saw that initially when the cell, when the plates of the cell were inserted in the electrolyte, that is H2SO4, the reaction started. That we know. That is H2SO4 got split into two H plus ions and one sulfate ion, right? This we know. So because of this, the charge accumulation started. We got positive charge on PbO2 plate and we got negative charge on lead plate, right? Accumulation of charge started. So initially, when we had just inserted the plates in the H2SO4, the charge accumulation rate कितनी तेजी से हो रहा था, that was maximum, and slowly the rate at which the charge was deposited on the plates, it goes on decreasing, and when the potential difference between the plates becomes E, when the potential difference becomes E, the motion of H plus ions towards PbO2 plates and the motion of SO4 sulfate ions towards lead plate, it stopped, right? Because of repulsive force. So accumulation was zero, accumulation ruk gaya. So at the voltage potential difference E, the charge accumulation rate became zero. So this is the graph showing you the charge accumulation rate versus potential difference. So the charge accumulation rate initially was very fast. Initially the reactions were taking very fast, the ions were moving very fast and they were getting deposited, the positive charges, the negative charges, they were getting deposited very fast. But they stopped when the potential difference reached the value E, that is EMF. Excellent. So this is the graph for that. Now, okay, then when we connected with an external circuit, जब हमने एक external circuit, when we connected an external circuit, now what is going to happen? The charge is going to discharge. The charge started flowing. जो charge accumulate हुआ था, negative charges, positive charges, they are now going to get discharged. They are now going to flow through the external circuit. So the rate at which the charges are going to get discharged, that is rate of flow of charges is what? Current. So the current will be maximum. This is your for current versus potential difference. So the current is maximum when the voltage is EMF, when the voltage is equals to EMF, right beta? And the current goes on decreasing when the voltage goes on decreasing. EMF, E maximum potential difference hota hai. So for maximum potential difference, for at the value of maximum potential difference, the current is maximum, but the current goes on decreasing. The current goes on decreasing with the decrease in the potential difference. है ना बेटा? अब ध्यान से देखना बेटा. Now we are having a very important point over here. That is this point. This point shows you the intersection of, this point shows you the intersection of the charge accumulation rate and charge discharge rate. इनका intersection point is this point, and we will say that the potential difference is V. Right, children? So this is the potential difference V. This is named as terminal potential difference. Right? I'll explain you this. But before that, suppose the potential difference. Suppose the potential difference value is less than this. Suppose it is at point A. A point P, you can see the value of potential difference is less than V. So at this point, if you compare the rate of charge accumulation and if you compare the rate of charge discharge, which one is higher, children? Which one is higher? Charge accumulation ka rate higher hai. Blue is higher as compared to yellow. So the charges will get accumulate very fast at this voltage, that is lower than V. So beta, at voltage lower than V, the charge accumulation rate is higher. So charge will get accumulated faster as compared to the discharge. And so the potential will increase because of the increase in the charge accumulation. And the voltage between the plates will become V. और पोटेंशियल डिफरेंस कितना हो जाएगा बेटा V हो जाएगा ठीक है अगर इससे वोल्टेज से इफ वी आर हैविंग अ हायर पोटेंशियल डिफरेंस सपोज हायर पोटेंशियल डिफरेंस है B पे right here beta if we compare the rate of discharge and we compare the rate of charging if we compare the rate of discharge red color and if we compare the rate of charging that is blue color which one is higher discharge ka rate higher hai right so here the discharge is higher so discharge will take faster as compared to accumulation so there will be discharge of the charges and as the charges will get discharged the potential difference will become less and it again comes to a value that is V. So V is the value at equilibrium. So V is the potential difference at equilibrium and it is named as and children it is named as terminal potential difference. It is named as terminal potential difference. So at this point V ये जो पॉइंट V है जहाँ पे दोनों के रेट दैट इज चार्जिंग रेट एंड डिस्चार्जिंग रेट ऑफ चार्ज is equal that at that point the potential is your terminal potential difference right so let's see the definition for terminal potential difference the potential drop across the terminal of the cell when a current is drawn from it is called terminal potential difference है ना बेटा तो बेटा ये वाला जो पोटेंशियल था पहले तो वो E था जब हमने कोई एक्सटर्नल सर्किट कनेक्ट नहीं की है मींस व्हेन वी आर नॉट ड्राइंग करंट एंड व्हेन वी कनेक्टेड एन एक्सटर्नल सर्किट when we connected an external circuit the voltage became V voltage कम हो गया so it means there is some voltage lost there is some voltage loss because we know E is greater than V तो कुछ वोल्टेज गायब हो गया कुछ वोल्टेज लॉस्ट हो गया व्हेन वी आर कनेक्टिंग एन एक्सटर्नल सर्किट सो दिस वोल्टेज इज नेम्ड एज द लॉस्ट वोल्ट सो लेट्स सी द डेफिनेशन फॉर दैट द डिक्रीज इन द वोल्ट when the circuit is switched from open to closed circuit is called the lost volt and it is denoted by the symbol that is VL. It is denoted by the symbol that is VL. Right beta? And as the current increases, jitna zyada current hoga, the lost voltage will be more. So as the current increases, the lost voltage will increase. So lost voltage and current, they are directly proportional to each other. And now we know if you want to remove the proportional sign, if we remove the proportional sign, then a constant will appear, right children? If we remove the proportional sign, then a constant will appear and that constant is Ri. So Ri is known as the internal resistance. Ri is known as the internal resistance of the cell. Cell के अंदर का जो resistance होता है, that is Ri. Right children? Now, okay. Now, so children, we know that E minus V is VL. This we know. Na beta? E minus V is VL. Now, if we make E subject of formula, E equals to V plus VL. Right? Now, pay attention on this diagram. Here in the diagram, we know that Ri, that is internal resistance, is the resistance which is offered by the electrolytes. It is offered by the electrolyte solution that is H2SO4 to the positive and negative ions. So it is the internal resistance, right? So that is over here, Ri. And here we are connecting an external resistance that is R. Now as we know that the current I is going to flow, right? So the current I flows through the external resistance R and the same current I is going to flow through the internal resistance R. I, right? But Ri. So can we write according to the Ohm's law, instead of V, we can write IR, and instead of VL, that is your lost potential, we can write IRI, right? Now taking I common, we will get R plus Ri. So R plus Ri, if you see, it is the equivalent resistance for series combination. Simple addition to series combination नहीं होता है ना बेटा. So if we make I subject of formula, I equals to E upon R plus Ri. So this is the value of current that is going to flow through the circuit when the current is drawn from the circuit. Right, children? So this is the derivation what we did, right? This is the derivation what we did, that is I equals to E upon R plus R. Your small r is your internal resistance, which we denoted by Ri. Okay, small r is Ri, right? And if you want to find V, simple, V equals to, just a second, V equals to IR. Instead of I will put this value and we'll get this equation, right children? And if you want to find the value of R, right? So from this equation we will get the value of R also, and that is this equation. Okay, beta? Okay. So fine children, we'll end our class here and we will continue tomorrow.